Hey, what's up? This is Randy. Today we're going to talk about even and odd functions. The graph that you're looking at right here is one example of an even function. In this lesson, you'll find out why. Here we go. Alright, so here's our plan for today. We're going to start by talking about even functions and how those can be identified both algebraically and graphically. And then we'll talk about odd functions and how those can be identified both algebraically and graphically. And then we'll go into some examples to practice what we learned. Now let me just make a quick point before we get into all the details. We all know that an even number is like 2, 4, 6, 8, etc. And an odd number is 1, 3, 5, 7, 9, etc. But I would encourage you to not think of these functions in the same way that we think of even and odd numbers, because it's really just not that simple. An even function cannot be directly tied to an even number, and an odd function cannot be directly tied to an odd number. So as you learn about what is an even function and what is an odd function, I would encourage you to temporarily just forget about your understanding of even and odd numbers so that you don't try to tie even and odd numbers to these concepts, because that will just confuse you. And honestly, to say temporarily forget is maybe not the right way to say that, but my point is, don't try to draw a straight line in your mind from even numbers to even functions and from odd numbers to odd functions, because it's not quite that simple. Alright, that said, let's start with even functions. How do we identify these types of functions algebraically and graphically? So let's start with the algebraic side of things. It says f of negative x is equal to f of x. But what is this really saying? Well, what this is saying is if you have a function, such as in this case, the graph that we're looking at is f of x equals 3 over x squared plus 2. If you take a negative x and you plug it in for every x in that function and you simplify, you should still get the exact same thing. Alright, so what is f of negative x? Well, f of negative x is when we put in a negative x, you can see I put a negative x right there, in place of every x in the equation. And what is f of x? Well, that's just the original function that they gave us. So I just wrote that function again on the right. Now, if this is an even function, f of negative x, when we simplify, should be exactly equivalent to f of x. Let's find out if that's the case. Obviously, it will be the case because I chose this as the example of an even function, but I'll show you how. So when we have a negative x in parentheses squared, is that the same as saying x squared? If it helps you understand it better, you can use some actual number for x. So I put in 2 for x here. So this is negative 2 times negative 2, we know is positive 4, right? Negative times negative is positive. All right, so we got 4. Now what happens if we plug in 2 for x over here on the right? 2 times 2 is 4. So when you have a negative number squared, that is the same as saying that number positive squared. So we can simplify negative x, all in parentheses, squared as x squared. All right, so algebraically, that's what it means when it says f of negative x equals f of x. If that happens, then we have an even function. Now, what is happening graphically? Well, an even function is simply a graph that has symmetry across the y-axis. You can see that the y values on the right are the same as the y values on the left. The difference is that here on the left, the x values are negative, and here on the right, the x values are positive. So any graph that has perfect symmetry across this y-axis is classified as an even function. All right, now what about odd functions? Let's start with the algebraic side of things. So we know that we have an odd function if f of negative x is equal to negative f of x. Now, f of negative x, we know, is when we put in a negative x for every x in the function. But what is negative f of x? This is when we multiply every term in the function by negative 1. This time we only have one term in this function, and it is 2x cubed. So negative f of x is negative 1 times 2x cubed, and f of negative x is 2 times negative x cubed. Now, if this left side and this right side both simplify to be the exact same thing, then we know that we have an odd function. Now, when we think about simplifying this negative x in parentheses to the power of 3, let's plug in an actual number so that we can think of it more concretely. Alright, so what is negative 2 times negative 2? That will give us a positive 4. And then times negative 2 will give us a negative 8 when we simplify negative 2 times negative 2 times negative 2. You're still going to get a negative. So if we put the parentheses outside of the exponent like that, it's still the same value. Now, negative x cubed is the same as saying negative 1 times x cubed. And now 2 times negative 1 is negative 2. So the simplified expression on the left is negative 2x cubed. Now what about the right side? That's much easier. We know that negative 1 times 2 is negative 2. And there it is. Once again, we get negative 2x cubed, just like we got on the left. All right, now what is an odd function graphically? We have an odd function if graphically we can reflect over the x and then the y-axis and have a function that is not changed. And this graph is a great example of that, because if we reflect, let's take this part of the graph, across the x-axis, it's going to show up right down here, right? Reflecting across the x-axis. And then if we reflect over the y-axis, this graph will go over there, and it will turn out to be exactly where the graph already was. Just like if we reflect this part over the x-axis, it will go up here, and then over the y-axis, and it will show up exactly where the graph already was. Alright, now let's apply this knowledge with a couple of examples. So here we have our key that we learned up above, and now let's figure out if this function right here is even, odd, or neither. Now either way, we need to find out what is f of negative x because it shows up in the even function and the odd function. So let's right away figure out what is f of negative x given this function. So I just plugged in negative x right here and right here. And now let's simplify even further. Alright, so there is our f of negative x cubed plus x. Now if it were even, we know that it would immediately be the same as f of x, which is this original function. Is x cubed minus x the same as negative x cubed plus x? No. So we know it's not an even function. What about an odd function? Let's see if negative f of x turns out to be the same as our result here when we simplify. Alright, so there we have the whole function multiplied by negative 1. Now let's distribute this negative 1 to both terms. And look at that. We get negative x cubed plus x and negative x cubed plus x, which means that f of negative x is equal to negative f of x. So we have an odd function. And that's the answer. Let's do one more example. Alright, so we have f of x equals x to the 4th minus 2x squared. So just like in the previous example, let's find f of negative x right away because that will be very useful for us. So right here we put in a negative x for x and again a negative x for x. Let's simplify even further. So because we have an even exponent, negative x to the 4th becomes x to the 4th. And again with an even exponent here, we get x squared in place of negative x squared. And now look at that. F of negative x is x to the 4th minus 2x squared, and f of x is x to the 4th minus 2x squared. That tells us that f of negative x is equal to f of x, and therefore we have an even function. Now remember, if we were to have an odd exponent here, like 3 for example, and an odd exponent here, then those negatives would not have disappeared, just like in the first example. But because we had even exponents there, both of those negatives disappeared. And there you go. Now you know how to identify even functions both algebraically and graphically, and odd functions both algebraically and graphically. See you next time.